Welcome to the last lesson of Unit 5. I know it's a quick unit. At the end here, we're just going to take a quiz. We're not going to do a test. It's just going to be a quiz. But today we are going to identify the pattern to get from the domain to the range and write a function rule from a table or situation. So in this lesson, we're going to work backwards from what we've done so far. Instead of giving you the function rule and having you create a table or find the range or do something like that, you are going to create the function rule. Okay, so you are creating the function rule. In the following tables, identify the pattern that gets you from the domain. Yeah, you know what? I'm going to scroll down first before I fill that in. Yeah, I want to identify the pattern that gets you from the domain to the range, and then use that pattern to write a function rule. Okay, so I'm going to go ahead and get rid of that, and I'm going to make this so that all fits on one so that we can look back at them all at the same time. So for number one, we want to look at the x values and see how do I get from x to f of x. I don't really care about going this way. I know that that's adding 2 each time. That's not what I'm looking at. Okay. What I'm looking at is how do I get from here, from x to f of x? And it's got to be consistent. So how do I get from 0 to 3? Well, I could add 3, right? Does that work for the next x value? 2 plus 3, does that equal 5? Yes, it does. 4 plus 3 equals 7. 6 plus 3 equals 9. We found it. The pattern is add 3. That's not the rule, though. The function rule is a little more detailed than that. So what am I adding 3 to? I'm adding 3 to the x value, right? So it's x plus 3. And when I do that, I get f of x, or whatever the function is. So that's the function rule. It's not hard. It's just detailed in how you write it. So the function rule in this case is f of x equals x plus 3. Let's look at the next one. How do I get from 0 to 0? Well, I can do a lot of different things. I could add 0, I could subtract 0, I could multiply by 0, or I could divide by 0. Or actually, I could do anything. 0 times anything is 0. So it's not a good one to look at. Let's look at the next one. How do I get from 1 to negative 4? I could subtract 5, but is 0 minus 5 0? No, so that's out. What's another way to get from 1 to negative 4? I could multiply by negative 4. Does that work? Well, 0 times negative 4 is 0, so it works there. 2 times negative 4 works there. Negative 3 times negative 4 is positive 12, works there. So multiply by negative 4. That looks like x minus 4. Let me back that up a little bit. All right, multiply by negative 4. Well, what are we multiplying by negative 4? We're multiplying negative 4 by the x value. So negative 4 times x gives me the f of x value. But in this case, I didn't label it f of x. I labeled it y. So I'm going to use that same label in my function rule. So y equals negative 4x. Okay. Number 3, a little harder here. Negative 2 to negative 7. Well, I could multiply that by 3.5. Probably not the way it's going to go, but it is possible. Or I could subtract 5. 4 minus 1 is 5. 4 minus 5 is negative 1. 6 minus 5 is 1. And 9 minus 5 is 4. So I'm subtracting 5. So the function rule is f of x equals x, the x value, whatever the x value is, minus 5. Number 4 is tricky. We'll tell you that. How do I get from 0 to 15? I could add 15, but 5 plus 15 is 20, not 10. I could, not sure what else I could do to get from 0 to 15. How about from 5 to 10? I could multiply by 2, but 0 times 2 is not 15, it's 0. So that didn't work. Look for any relationship between these two. And it doesn't have to go from x to f of x. It if you look at all of them together, if I add the two things together, it gives me 15, right? If I add the x value plus the f of x value, it adds to 15. 0 plus 15 is 15. 5 plus 10, 15. 10 plus 5, 15. 14 plus 1, 15. That's a relationship. Now, what I'm going to do is I want to get my function rule. So f of x, I want to get by itself. So what I'm going to do is I'm going to subtract x from both sides. And that actually gives me my function rule. So the f of x equals 15 minus x. Okay. So that actually can be found by just seeing a relationship between x and f of x. All right, so let's look at the end of this. In problem 4, what is f of 20? So real quick, I'll write down again what the function rule was. It was 15 minus x. What is f of 20? So I'm saying, this is review here. If I put 20 in for x, what do I get out? And I would get -5. Now this is a little bit new. What is the x value when f of x equals 3? So I'm telling you that the y value, this is 3. What is this? Well, where I'm going to put the 3 is in for the whole f of x. So I'm going to write that out. 3 equals 15 minus x. Now, if I solve that, you should be able to do this in your head, but if not, you could solve it algebraically. You get x equals 12. So when x equals 12, f of x equals 3. And you can see that. If I put 12 in for x, 15 minus 12 is 3. All right. So that's from a table. What about a word problem or an application? A cup of frozen yogurt at Yo-Yo costs 49 cents per ounce. Write a function rule to determine the final cost, and I'm telling you what to label it, C of n, of buying n ounces of frozen yogurt. Well, the total cost, C of n, will be equal to the number of ounces that you buy times the price per ounce. So it's 49 cents times the number of ounces. That's a pretty basic function rule, but that is the function rule. Notice the labels I'm using. I'm not using f of x here because I didn't want to use f of x. It's C of n is standing for cost based on number of ounces. Okay. How much would a cup that weighs 8 ounces cost? So I'm looking for C of 8. So it's 0.49 times 8. So you pull out your calculator. It's going to be just under $4. I think it's $3.92. Yep. It would cost $3.92 before tax. How many ounces could you buy with $6, assuming no tax? Let's just say assume no tax. $6 could be the total cost. So that goes in for C of n. So 6 equals 0.49 n divided by 0.49. You're going to get a nasty number. If we're looking at only full ounces, 12.24, you could only get 12 ounces. Okay. Let's move on to the next one. To rent a hot air balloon, it costs $200, just a flat fee, plus $21 per hour. Write a function rule to determine the final cost of renting hot air balloons for H hours. So again, I changed it up a little bit. I want you using C of H, where H is representing the hours. Well, it's $200 regardless. But there's a plus $21 per hour. Okay. How much would it cost to rent a hot air balloon for 6 hours? Well, I'm asking you for the C of 6. So it's going to be $200 plus whatever 21 times 6 is. So 21 times 6 is 126 plus the 200. It's going to cost you $326. How many hours could you rent a hot air balloon if you had $400? You could kind of keep just counting, but an easier way would be put $400 in for C of H. Subtract the 200 and then divide by 21. And you do have to round to the nearest whole hour. Not nearest, can't go over. So you get 9.52, which would round to 10. But if I round up, it's actually going to cost me more than $400. So I can only have this for 9 hours. Got to round this one down. All right. One more of these, and it's a trickier one. Write a function rule to determine the change you would get from a $20 bill when you purchased items that cost $1.25 each. Let's say you're going to a garage sale. They have a table where everything's $1.25. You grab a certain number of items and you go and you pay with a $20 bill. Okay. We want to determine the change you would get from a $20 bill. I didn't tell you what to use for variables, so if I don't tell you, you get to pick. So I'll just say f of x and x. So f of x equals, well, how do you determine change? Well, you always start with what you paid with and you subtract the cost. So I started with 20 and I'm subtracting the cost. Well, what goes into the cost? Well, it's $1.25 per item. So it depends on how many items you bought. So it'd be 1.25 times the number of items you bought. So there is my function rule. How much change do you receive when you purchase 5 items? So you pay with a 20. And the cost was 125 times 5, which is $6.25. So it cost $6.25, but I paid with a 20. 20 minus $6.25 is $13.75 would be how much change I would get. Can you purchase 17 items with a $20 bill? Okay, well, let's see. I'd put 17 in for X and see if I could do it. Now, what does that look like? Well, let's do the math real quick. All right, so 125 times 17 is 21.25, and you probably understand that you can't buy it because you only have $20. You would still owe 125, so you would have to put one of the items back. So it costs too much. Okay, and that is writing function rules. And that concludes Unit 5. And like I said, there's going to be a quiz on this shortly.